The demodulator for the caller ID project is based on a phase lock loop component, and the PLL will form the basis of FSK demodulation. First off, we need the passband version of this subVI. And taking a quick glance at the inputs and the outputs, we see we have a couple that are tucked on the top and the bottom as well. And we'll need about half of these input and output connections. So I encourage you to check out the detailed help on this. In particular, look at the version for passband, because there's two different help pages in there. I'd also encourage you to check out that theory of operation for the PLL, or what they call the phase lock loop details. And we have a number of different options in terms of the loop filter, and this is the version that we need here. The transfer function is simply 1, so we need a unit coefficient in both the denominator of our filter polynomial and the numerator of the filter polynomial. So I'll begin by creating a constant, and this, as we see, is an array of coefficients. And I only want a 1 in the 0th order coefficient. So in fact, what I need to do is really delete that one. And then I need to wire this to both the forward and reverse coefficient inputs. All right, I want to bring out the VCO gain and VCO carrier frequency as controls. Sometimes the wiring gets a little bit cramped here. Hopefully you have a larger display that you're working with right now. Also create a control for the waveform input, and this would be essentially our FSK signal coming straight from the caller ID signal embedded between the first and second ringer pulses. Now here's a nice way to extract the output that we need, which is the phase error from the PLL. And this combines that phase error signal with the sampling frequency, and we generate a suitable waveform data type for the output signal. And this is our baseband signal that's been recovered from the FSK signal. All right, we also want to be able to indicate where when the PLL has established lock. And the basic idea involves the absolute value or magnitude of the baseband signal followed by a low-pass filter. All right, so we'll take the baseband signal, pass that through the absolute value, and that output signal is to be made available in case we need to confirm that our demodulator is working properly. Not really a primary output, but something that might be useful to look at. Now the main output here, in terms of indicating whether or not the PLL is locked, has to do with the magnitude of that signal. So again, the general idea here is that anytime the phase error starts having a large, rapidly changing value, we want to discriminate against that behavior. So I'm looking for places where the output of the filter is below some threshold. Alright, do a right click here and specify a constant first, and most of these we can just accept as default. For example, the Butterworth filter, low pass data type, and so on. The one that I would like to be able to manage from a front panel control is the low pass corner frequency. So we can use bundle by name, and then when you pipe in that big constant, you can just pick the one that needs changing. In this case, it's the parameter called lower FC. And for our purposes, we need a little bit different name for that one. Alright, now we use the modified version of that cluster. And we're pretty much set. I'm going to go ahead and change that to a second order. Gives just a little bit better performance. That takes care of the demodulator.